Hi everyone. Hi Kshitij. Thanks for setting this up.
Hi, Chirag. No worries. I think let's give it another
Hey,
minute.
Kshitij, bye.
Sure.
Hi, Ahmed.
Hi, Satish.
Hi. So it seems we are going to have good attendance today. So yeah, around 15 people already there, 16. Good. On a Saturday morning or afternoon if you are in India. Hi.
Yeah. Yeah. Saturday morning, 10 a.m.
People are quite passionate,
Ev-
it seems, for generative
I would.
AI. My wife
Well,
was saying, "What are you
yeah.
doing? Why are you troubling people on a Saturday?"
No, the last one, the first one was
Yeah,
really good. I mean, that's I think inspired everyone to
that's
join
really
back,
good.
and the group has grown as well, which
Yeah.
is great.
Okay, cool. I think because it could be a long one, then I have to be constrained for 1 hour. So let me start. So people will keep joining. Let me start. Let me share my screen. So screen is visible.
Yeah, we can see it.
Yes.
Okay, let me play it. Okay, cool. So, hi guys. This would actually be a session on generative AI for absolute beginners. So that's why I call it absolute beginners. It's not on only beginners, but I'd say people who are actually new to AI, to generative AI, and they want to make it a start, right? They want the first step. So it's for those folks, and I believe I have the right audience, right? So yeah, so let's get started. So just a few things about myself. I'm Kshitij Joy. I'm a member of a lead group of Oracle professionals. So I completed my OCM, which is Oracle Certified Master, the certification from Oracle. I was awarded Oracle Ace Pro by Oracle Corporation. It's an award from Oracle. I actually, apart from teaching and what I do now, I do have a day job. I work as a cloud architect and a security architect for a major European bank. I have been a presenter at various user groups like UK OUG, NL OUG, Austria Oracle Group, and even in Vegas for Oracle Cloud World. So I have been an instructor of several bestseller courses on Udemy. You can find me on Udemy. So on Udemy, I've got around, I think, 10 or 12 courses now. And there is one specific on generative AI, and it's like a 15-hour course now. And I keep adding new content to it. Like I added something recently on agents. And what I'm going to tell you today is a kind of a snippet, a 1 hour snippet of that, like, but more for absolute beginners. And I recently launched one on Olama, which is actually a way in which you can run LLMs. Did you know that you can run LLMs like DeepSeek, MetaLlama on your laptop or on your device itself? So, right, so that is there. And I'm actually currently working on an agents courses. Anyways, and yeah, I did an experiment with Coursera. So Coursera approached me, and so I did create a couple of courses on Coursera. Also, nice experience, I'd say. I do have specialization in Oracle. So you can see my CV or my profile is too Oracle heavy, right? Because Oracle has always been my first love. So I started my career in Oracle, worked throughout. So now I'm actually going to talk about my new fascination, I'd say, because first love is still Oracle. First love can't change. So the new fascination is Gen AI, right? So let's get started. So we'll actually start from the very beginning, which is artificial intelligence. Right? So the thing with artificial intelligence is a lot of people say, "Oh, I have to remember the definition. The definition is very difficult. How do I learn AI? All that stuff." So I always say that look at the root word, right? What is the root word? So root word is artificial and intelligence. Now, if you break it, what is artificial? If you think about it, artificial is something that is man-made or something that is actually not occurring in a natural format. So this is something we call artificial. Then you talk about intelligence, right? What is intelligence? So intelligence is the ability to acquire and apply knowledge and skills, right? So this is what we call intelligence. If you're saying somebody has intelligence, you have the ability to acquire and apply those skills or knowledge. So now if you look at the definition and what the definition says, it says it is a capability of a computer system, right? Now we are talking about a computer system. We're not talking about humans anymore. You will always see that there will be a kind of a mapping going on between what humans can do and what machines can do with artificial intelligence. And it says it is a capability of a computer system to mimic. So mimic means to copy, right? Human-like cognitive functions. Now you might ask, what are cognitive? Cognitive is like learning, right? Reasoning, remembering. I don't normally say LRR. So learning, reasoning, remembering. If you can bring all these qualities, what a human has, into a computer, then we can say you are able to do some cognitive functions, right? That's simple definition of AI. And what I've done is I've actually, because it's for absolute beginners, I've gone with a
most advanced chessboard.
small demo. Are you able to hear it?
You the infinite possibilities of online chess, engaging experience of a physical set. And Phantom is also the smartest board ever. It allows you to play against any other human on Earth remotely, or moving the pieces using only your voice.
Knight G4.
Play against our human-like AI, which continuously adapts to your playing level. The pieces become a sculpture that plays back the most famous games in history. Phantom, it's bringing back all the little details that make chess great.
Okay. So this is like a very perfect example, I would say, for a beginner. If you want to see AI in a demo, kind of like, okay, how, when you say AI, okay, you told me the definition of AI, but I want to see AI really functioning for me. So I think this is a perfect example where a person is saying Knight G4. You're just speaking in a normal natural language format, and the job is getting done for you. That's just a very simple example, right? Now, the thing is, my dad always used to say, and always says, that whenever you are studying a new subject, always look at its history. It's very important, because if you start looking back at the history, then you will actually get to know a lot of things. And that's what I've done here. I actually went back, I went through the internet and came up with a timeline. Like, what kind of timeline are we looking at with AI? And you'll be surprised. And I was even surprised, because AI is so hot these days, but it actually started from 1950s. So Alan Turing was a guy who published a white paper, you can say, on computing machinery and intelligence. It was kind of called a Turing test. So what it said was that if you are getting an output, if you are not able to distinguish that the output is of a human or a computer, then you have passed the Turing test. It means the computer has passed the test. Then came John McCarthy, and he coined the term. So if somebody asks who's the father of artificial intelligence, I would say it's John McCarthy. He actually coined the term. The artificial intelligence was coined back in 1956. Then in 60s, you can read about it. Frank Rosenblatt builds the perceptron, the first computer based on neural networks. So just think about it. What we are studying today, neural network, was devised sometime back even in 60s, right? And in 80s, things changed, and neural networks became more mature, and there was a concept of backpropagation. We'll take a look into that as well. But just to think about it, with backpropagation, what is happening? So the first one was forward propagation, where you're just going forward. With backward propagation, you can actually adjust the weights, biases, all that stuff. So you are learning from your mistakes, right? Then I still remember that day when it was in the news when IBM's Deep Blue actually beat Garry Kasparov. I do remember. I think I was in the school that time, probably, or college, but it was in the news that, hey, Garry Kasparov has been defeated by a computer, and that was from IBM. Then there was a game, Jeopardy, and if you see here, the computer is winning, right? These guys are losing, and the computer, this is the computer in between. Then in 2015, we talk about supercomputers, where Baidu actually came up with a supercomputer which could look at images and with a very high rate of accuracy, just like humans. Then 2016 was also nice, where AlphaGo program was created, and it was DeepMind's AlphaGo program. But I really see this 2020s as a game changer, and I think you guys will agree to that. why suddenly AI has become so hot? Why so much fuss about it? I think OpenAI actually released GPT-3. It was one of the most sophisticated language AI processing models. Sorry?
Is going through the history of it.
Yeah, we're doing the history of AI. Sorry, can we keep the questions for the end, please? And if you're not speaking, if you could go on mute, please. Sorry. Yeah, so it was capable of generating human-like text, right? So now there's a transition from more of predictive AI to more generative AI. And that's what we have to study. Because what is generative AI? So this is where I see it as a game changer. AI was always with us. It has always been with us. But when this new wave of generative AI came, people just were shocked. Like, hey, it's now going to become part of our daily life. People will lose jobs and all that fuss about AI, generative AI stuff. Right? Okay, quickly we'll take a look at what are the benefits of AI. Now, we all agree that humans make mistakes, right? You look at any of the outages, right? Most of the time, 80%, I would say, or even 90% of the time, those outages are related to some human mistake. Now, here we are saying, once a code is done, it's up and running, it's running fine, no human error, right? With AI, if there is no human error, if the human element is removed, then obviously there is no human error, right? Then we talk about the 24/7 availability. We are humans, right? We work in shifts. We'll say, oh, I work in EMEA, I work in UK. I'll work 8. I don't want to work after 4 o'clock. But machines are not like that. You run the code, you run the machine, they'll be available for you 24/7. Then we talk about unbiased decisions, very important. Believe it or not, but humans are biased. We are biased, right? It could be based on sex, creed, religion. We always take decisions based on biasness. Now, there is some level of biasness with machines, but that biasness has also been created by humans only. But in general, we can say with AI, you are making unbiased decisions. And yes, you can make quicker decision making. Just look at the news where they were saying that the scientists were working, and I think they were working for last 20 years. And when the whole thing about AI and Gen AI started, they started working with the LLMs. They were able to process it within 2 days or something. So it's quicker decision making that helps. And then we talk about less risk. Obviously, if you are less biased, if there is no human error involved, obviously there will be less risk as well. And yes, another problem with humans is they get bored very easily. If I ask you to run a script every day at 8 o'clock in the morning, you'll say, hey, are you paying me for this kind of job, right? So, but computers don't. They don't complain. They are ready. They are happy if you want to run a recurring mundane task even, right? Now, we'll quickly take a look at some of the workloads with AI, right? The first one is machine learning, computer vision, natural language. Again, what I've done is I've taken a very, very small video of each and every aspect so that you can correlate. Because if I just tell machine learning, it's a way we teach a computer model to make predictions and draw conclusions. Okay, but let's quickly take a look at a video.
Is trying different algorithms and letting our members tell us what sort of experience actually work out for them. So we can make sure that whatever choice we make is the one choice that improves joy for our member base.
Through the process of A/B testing, you learn what the next challenge.
Okay, so this is a very small snippet because I used to think, okay, if I have to explain machine learning to someone, how would I explain? Or what is the real world use case? I used to always think. So there's a perfect example taken from Netflix. So they are just trying to explain that how they use Netflix and you'll see further as well. But they're just talking about A/B testing, which is a way in you check, okay, is option A better for the people or option B better for the people, right? Then very quickly, we take a look at computer vision. Now, till now, a photograph was a photograph, a video was a video. But did you even imagine that you could identify objects out of a photograph, objects out of an image, or objects out of even say video, right? That's what computer vision brings you, right? It is the capability to interpret the world visually through cameras, video, images. Okay, so you can see, you can identify every object, right? This capability was never there, right? Or previously not there with us. Then another key example, it has been around us all the time and we never realized. I didn't realize. We've been using Alexa for so long, right? What is it? It is natural language processing. It is able to understand your natural language, the way you are speaking in Hindi, you are speaking in English, or any other language. And then the computer is able to work for you, right? So it's a capability within AI for a computer to interpret written or spoken language and respond in kind. So it can understand and it can respond.
Alexa, open Amazon Map. Welcome to Amazon Map, a fun place where we can practice math together. Well done. Next question. You got 5 out of 5 correct.
Alexa, announce I finished homework.
Okay, right. Now, a very quick example in generative AI. So till now, as I said, we are doing more making predictions and all. But now with the capabilities of generative AI, you are able to create original content, right? It is always, they say it's original. It is generated on the fly, right? When you ask a question to ChatGPT, or you ask it to write a poem, something, a story, it is generating on the fly, right? And we'll take a look how this is done as well. So it is a capability within AI that can create original content in a variety of formats, like it could be natural language, image, code, or more. Okay, so these are a few. There could be more, like you can do speech to text, you can do text to speech as well. These capabilities are there as well. Right. Now, very important question on Gen AI. Now, when I started studying and when I started looking at Gen AI, I thought, okay, I'll actually start learning Gen AI. But then I realized, no, it's not possible. Why it's not possible? Because Gen AI sits somewhere here and I am here, right? Just think like an onion, right? If you have to go into the inner layer of an onion, you have to go from the outer layers first, right? Till the time you understand, you go deep dive, only then you can hit the layer of Gen AI, right? That's the key magic of Gen AI. And if you look at it, this is how it works. The topmost layer is artificial intelligence, then comes machine learning, then comes deep learning, and then comes Gen AI. So if you say, today I'm learning Gen AI, but I don't know, or okay, I know artificial intelligence, what are you telling me about? But do you really know machine learning? Do you really know deep learning? Because these are the key topics, or I would say these are the foundation on which Gen AI stands today, right? And we'll take a look into that as well. Okay, so we'll go with first one. So AI, I think by now everybody understands what is AI. We looked at types of workloads. We looked at benefits of AI. I think it's good time to start machine learning foundations. Now, what I've done here is I've actually taken some key terminologies, which are very important. Now, just imagine you are working in your company, right? And you are talking to a data scientist, or you're talking to one of your CTOs or your managers, and the guy is saying, oh, what kind of algorithm would you be using? What model you're using? Okay, are you training your model or not? What label are you using? So you are feeling a bit confused, right? What is training? I always used to feel confused. Like when somebody tells me, or my manager used to say, we're going to train this. I used to say, how can you train a machine? That's like, it used to go over my head. It was like a bouncer for me. So then I thought, okay, why not come up with these in one place and look at it? So let's take it one by one. First is algorithm. So remember, everything what we are going to do, or which is happening behind the scenes, it's all math. It's all statistics. They are all complex mathematics, advanced statistics that is happening, right? This is not visible to us because there is so many layers on top of it. And for a user or even a programmer or a developer, we don't come to know what's the magic or the statistics behind. So anyway, so algorithm, like in a normal way, if you've been studying mathematics, the algorithm is actually It refers to a set of rules. What is an algorithm? If you say, what is the algorithm of relativity or any specific thing you are learning? So it is nothing but it is a set of rules and statistical techniques that are used to learn from data. So you have to learn from the data. Now comes the model, right? And we'll take a look at it if it's still a bit confusing. So it says a model is a learned representation of the data created by an algorithm to identify patterns or make decisions. So always remember your data will always have patterns. And that is what the data scientists were doing. They were looking at patterns, right? How can I derive decision-making out of those patterns, right? So that is what we are doing. We are creating a model from the learned representation of data. And here it says, like, after feeding a data set of house features and prices to a regression algorithm, the model it creates can predict price for a new house, right? Let's say you put, okay, today I have got a 2-bedroom house. I've got a balcony. I've got a good driveway. Give me a prediction. What will be the price of my house, right? So this is, I'm sending it through a model, right? Because my model has been created. Now my model has been created based on an algorithm, and I would have given a lot of data to it saying, if it is a 2-bedroom house, your price should be in this range. If it is a 3-bedroom house, your price should be in this range. If it's a 4, in this range. Now, when I start giving it some features, then it's able to tell me, oh, yeah, based on this, I can tell you that your price would be in this range, right? This is what we call training. You're presenting the data, right? You're giving the data to a machine learning algorithm to create a model, right? Very important. You're creating a model based on the training, right? You hear this term so much, training. Oh, OpenAI has trained on this much data and all that stuff, right? And like neural network shown thousands of pictures of cats and dogs during training, and labels are the outputs that you want the model to predict. So think of it, a label is like what output you want. If the feature is like this, if it's a 2-bedroom house, my prediction should be this. If it is a 3-bedroom house, my prediction, that is the kind of a label, right? Again, quick real world example on machine learning.
Netflix, we have over 120 million members. They span the whole globe across 190 different countries, as well as a diversity of titles, content, comedies, and dramas.
Machine learning is deeply intertwined with all aspects of Netflix's business, how we compose our catalog of content, how we produce our content, how we encode it, how we stream it. We use machine learning to help marketing efforts and advertising efforts. And then we also use machine learning in our content acquisition effort.
Okay, so another perfect example where they're telling that we are using machine learning everywhere, right? Another good example can be the recommendation, right? You get emails where they say, hey, they've come up with a thriller movie because they know that you like thriller movies. So they will send recommendations to you, right? That is all machine learning. They know the pattern of your behavior. They know what kind of movies you like. That's what they are doing, right? Okay, now coming to the deep dive of machine learning. Again, you told me everything. Still, I'm not 100% sure what is machine learning. I'm still thinking, and I was in your shoes as well. If you're thinking that way, still, I used to think, fine, you told me everything. You told me algorithm, model, and all, but I'm still not able to visualize how can a machine learn. Okay, I'm a human being. I can learn. That's fine. But how can a machine learn? So the best way I thought is think of a baby, right? Think when a baby is born, is a baby able to distinguish between a dog, a cat, or a horse? Do you think that? A baby is born, ask the baby, hey, tell me which one is cat, which one is dog? No, because the baby or a human is learning over time, right? It's taking time for a person or a baby to learn. And how will a baby learn? Now think about it. A baby will learn through examples, right? Show him, or he or she will see different cats and dogs on the streets. They can distinguish, or they will read in the books. Teachers will tell them, see, this is how a cat looks like. This is how a dog looks like. This is how a horse looks like. And the baby is able to distinguish that. Then baby can understand from the diagrams, right? you can see, okay, if it has a long ear, black nose, probably it's a dog, right? Long ears, black nose, it's a dog. You're just learning, right? You can even learn by examples, by diagrams and comparisons, right? Now, you should be able to distinguish between a cat, dog, and horse. Then again, when you will be shown images, pictures, or a cat or a dog comes in front of you, you should be able to distinguish, right? So what is machine learning? Now, going into the actual definition of it, it's a branch of AI, right? Now you are with me. It's a branch of AI. We know that onion structure, which focuses on the use of data and algorithms. Again, right? The focus is on data. See, data is still the powerhouse here. People say we are doing AI, but we don't know about our data, then you are at the wrong place. Data is still the lifeblood. So which focuses on the use of data and algorithms to imitate. Again, imitate, copy the way humans learn, gradually improving its accuracy, right? So think about a baby again, right? Learning, you are also improving over time. You are not born perfect, right? You learn and then you gradually become perfect. That's what we are trying to do with machines, right? So in machine learning, computers apply statistical learning techniques to automatically identify patterns in the data. Now I'll give you two P's that you have to remember always. One is pattern, other is prediction. You are looking at the patterns to make predictions. Always remember with machine learning, that is the magic behind. See, your data always contains patterns. As I said, you will always have some patterns in your data. That is the logic. You need to find the patterns. You need to train the algorithm, recognize the pattern, and build a model, right? So from here, this we call as training data, right? This is my training data, right? So with this training data, I was able to find the pattern, recognize the pattern, and I built a model. Now a model is created. Now I will use this model. So this model has been created. I will use this model and I'll bring a new data, and we call it as testing data. Always remember, training data is different from the testing data. Now you bring this testing data, you pass through this model, and you get the prediction, right? So pattern, prediction. So as I said, those patterns are then used to create a data model that can make predictions. And with increased data and experience, the results are more accurate, right? That's why we say, keep doing this, keep doing this. That's why OpenAI has been going for this learning. When they say they are training, keep doing the training to improve, because at the end of the day, we want to improve. Okay, another thing, I gave you two P's. I'm also giving you two Q's today. Always remember these two Q's. What are these two Q's? One is that you are heavily relying on your data, but you rely on quality and quantity. These two are very important. Your quality is important, but your quantity is also important, especially with machine learning, because you need examples, you need comparisons, you need a lot of features to understand. And that is only possible if your quality is good, if your quantity is good. And then it's just a quick about applications, like what applications are available. Like you have healthcare, finance, autonomous vehicles, and tasks like prediction, classification, clustering. We'll take a look into that as well, right? So this is machine learning. Okay, very quickly, we look at types of machine learning. Now, this is like a broad category of machine learning. We call it supervised machine learning. We call it unsupervised and reinforcement, right? And what I'll do is I'll give you one example each of these, right? So it says model training with labeled data. Now you can identify when I say labeled data. What was labeled data? Where you know the output beforehand, right? You already know if this is this, if this feature is this, then this is this, right? So in here, we take an example of classification, right? Perfect example of classification, they say, is that you're running a classifier and you are, let's say, having a Gmail, right? So in the background, they are using this classification machine learning where they are able to identify, okay, in your inbox, this is spam and this is not spam, right? So they are able to categorize or classify. Then we talk about regression, right? regression is something like where they say that, okay, there is a line of regression. This is something they call like they plot the graph. And what they are doing is they are actually looking at the house price prediction. And this is the size. I think it's not visible. Let me just hide it. Sorry. Yeah. So this is the size of the house, right? And this is the price. So what it is saying is, as the size of house is increasing, your price of the house is also increasing. And this way they are able to plot it. And this is called regression, right? So this is a perfect example, house price prediction. If you build something today, you put your house price. If you put a house size, maybe you would have seen in Zoopla.com or in Rightmove, you put your house size, right? It's able to give you a rough estimate. Hey, your today's price would be something like that. It would be looking at several other factors, but again, this is a kind of a regression that is happening. Then we talk about unsupervised learning. So with unsupervised learning, they say the model training is done with unlabeled data. Now there are circumstances where you don't have the labeled data. And the perfect example is clustering. Now the best example I take with clustering is something like this. It could be with Netflix movies, but as I said, I teach on Udemy. A lot of my students are given something like this. And then I said, wow, that's a perfect example of clustering. Because if you see, it says frequently brought together. If you are a student, if you are interested in, let's say, Oracle databases, OCR, you should take these courses together. This is what they have done as a cluster. They've created a cluster for the students, right? Then we talk about reinforcement learning. Now, with reinforcement learning, what happens is models take actions in the environment, then receive the state updates and feedback. So this is based on reward and penalties, we say. And the best example is the chessboard, right? With chess, if a computer makes a wrong move, it learns from that mistake, right? It learns, hey, I made a wrong mistake. I shouldn't be making that again, right? So this is what we call reinforcement learning. And you'd be surprised that recently DeepSeek that was released, in the back end, it is based on reinforcement learning, right? So these things were already there, and these have been there for ages, right? So this is like a kind of types of machine learning. Okay, time for a quick live demo. I'll do, let's say, as they say, the demo gods, I hope, are with us. So what I've done is I have actually, should be here. Yeah. So I've taken an example, right? So this example is of a flower. It's an iris flower, right? So now iris flower has certain varieties. It has iris setosa, right? It is iris veriscular, and it is iris virginica, right? So 3 types of iris flowers are there, right? Because I wanted to come up with a very simple example so that I can tell someone, hey, this is machine learning, because I was still not getting confident when we say machine learning. I wanted to use my hands and just test something out, right? So this is your labeled data, right? This is the kind of output. And these are your features. So I'm saying if a flower has certain sepal length, certain sepal width, certain petal length, certain petal width, then it belongs to the category of iris setosa. If it has certain other, then it belongs to iris veriscular. So that is the data. This is my data set, right? And what I've done is I have actually taken an example. So what I'm doing is, this is a library I'm using. It's a pandas library, Python library. And I'm reading this data, right? It's iris.csv. And I'm printing this data, right? So if I execute this, you'll see it gives me the output, right? The output is, this is the ID, and it's just the head, like just the first top part of it. Then I'm saying, okay, but I need something on the x-axis, something on the y-axis, right? So what I'm going to do is for the x, so x is nothing but my features, sepal length, sepal width, all that stuff. So that's where out of this data, I'm going to drop the columns ID and species. So I'm going to drop this column, I'm going to drop this column, right? And with Y, I'm saying data species. So this becomes my Y. So think about it. X is your all the features, Y is your species, right? So I drop it, right? And then I print the X. So if you see, I print the X, now only sepal length, sepal width, petal length, petal width are shown. Rest of the data is gone. I print the Y. right? When I print the Y, you will see only the varieties of the flower are visible, right? Which is Iris setosa, virginica, all the features are gone. This is where I create a machine learning model, right? Now, as told you, model is based on an algorithm, right? Now, the algorithm I'm using, it's already there, which is logistic regression. This is something what we learned about regression. So logistic regression is my, say, algorithm. Based on that, I'm creating a model, right? Now, once I have created my model, what did we learn? We learned that the model is, so you have to now train that model, right? So you're training the model on the features, right? What are the features? X. And because it's a trained data set with the outputs, I'm getting S, X, and Y, right? Now I've trained the model. Now I'm going to test. So this is my testing data. That was my training data. This is my testing data. Now the aim is, if I tell the computer that, hey, my features are this, you need to tell me whether this belongs to Iris setosa, varicella, or whatever it is, right? And that's what the model will predict. If I print, it will show me it is Iris setosa, right? So that's a perfect example of machine learning and how it works. Okay, the demo went well. So let's quickly go into the deep learning side of the things. Now, the things started getting quite exciting, right? And the thing with humans is that humans are never satisfied, right? They want to keep learning. They want to keep innovating. Now they thought, okay, fine, machine learning is good. We are happy. Machines are able to do the tasks for us. But still, they are not as close to the human brain, right? And the aim was to bring the machines as close to the human brain. Now, with human brain, they say, and when I was studying, I also came across this thing. There is a concept of neurons, right? You think whatever we do, you know, head to toe, our whole body is connected with neurons. Whatever we do, like eating, drinking, sleeping, relaxing, all these messages, they say these are electrical impulses that are sent from one neuron to next neuron, right? This is how a human brain works, right? And what does deep learning say? Deep learning says it is a machine learning technique, right? Again, your onion structure. Now you are going a deep inside, a layer inside. It's a machine learning technique that teaches computers to process the data in a way inspired by the human brain, right? So we are getting as close as to a human brain. But how is that possible? Now comes the concept of neural networks, and we'll take a look at that as well. So at the heart of deep learning are artificial neural networks. Now here, these are actual neurons inside a human brain. Scientists thought, why don't we make artificial neurons? The way messages or electrical impulses are being sent from head to toe, and our brain is functioning so well, and why don't we put the same thing inside machines, right? So, and as we said, a human brain contains millions of interconnected neurons that work together to learn and process information. Now, whatever is happening inside our body, the learning, the processing, these neurons are actually participating in that, right? So this is where artificial neural networks came into picture. They said, okay, why don't we build something with millions and millions of these layers? And this is where we say artificial neural networks are made of many layers of artificial neurons. This is human brain. Again, this is neurons. These are artificial neurons. These all are artificial neurons, right? And very, very important thing. Okay, now if you look at that example we studied, you had an input. So there was a human actually involved in a feature extraction, right? You were saying, okay, if let's say if this is the feature, then it should be Iris. So if this is the feature, it should be Iris varicella. And then I'm passing through the classification, and then I'm getting an output, right? We already saw classification. They said, why are we actually putting a human here? Why don't we get rid of this entire stuff, right, and put it inside this? So this whole thing is gone now in deep learning, and you are sending the photographs. It is going through an artificial neural network, and it is able to distinguish whether it's a car or it's not a car, right? So eventually humans are trying to get rid of humans to make their life easy, right? So that is deep learning. So, and this is what it says. It automates feature extraction, removing some of the dependency on the human experts. Probably you were hiring data scientists, you were hiring a lot of other folks who were actually looking at that feature extraction side of the things. That is all gone.
Sorry to interrupt you. Anmol just was kicked out of the meeting. Could you please let him in again? Anmol, thank you.
Yeah, sure. Oh yeah, thank you so much. So Anmol, where is Anmol? I can't see him now. No, I think, or can I make someone else?
Yeah, you can make me co-host, Satish. I can add people.
Manoj, okay, yeah. Thanks, Manoj. I'll make a couple of guys. I'll make Amit. Okay, right. Okay, cool. Yeah, where were we? Let me go back. Yeah, okay. So we talked about the feature extraction, right? Okay, so it says why the name deep, first of all, right? So as I said, always look at the root word, and that's my mantra. I always look at the root. The deep reasoning is because of the number of layers it has to go through, right? So deep consists of layers of interconnected nodes or neurons, and deep refers to the number of layers. That's why we say deep, because there are so many layers of these artificial neurons that are interconnected with each other. That is what it makes a deep learning. And again, because you are expected to do so much work, obviously you need more computational resources, and we'll take a look at GPUs and all as well. Right, and it has various versatile applications like natural language processing and all, right? So very quickly, we'll take a look at a neural network. Now, I won't go into the too much deep. So deep learning, what we studied, is based on neural network, right? So again, a neural network is a machine learning program or a model that makes decisions in a manner similar to human brain by using processes that mimic or copy the way biological neurons work together to identify the phenomena. I don't think so you need to learn this definition anymore, right? Now you can easily understand that, yes, how a neural network works. So a neural network is comprised of layers of interconnected nodes. By now, I think you know what we saw, or neurons. We say either nodes or neurons. So this is your input layer, right? Then you have some hidden layers. They say there are a lot of hidden layers. That's why it makes it deep, right? And then you have an output layer. Now here they take an example. They say, like, let's say, and this is you're giving this image, and you need to identify whether it is a circle, a square, or a triangle, right? So this is how they're saying, like, how it passes through a neural network. So this would be your input layer. This could be all your pixels, right? And this is a concept of weights. So this would be your weights, and these are your biases. And do you know the entire magic of these LLMs? Why ChatGPT is better than say Llama, or why DeepSeek today is so good than other models? This is the magic of weights and biases. These are just mathematical numbers, right, based on which these calculations are being done, right? So again, as I said, this is all statistics at the back end, but there's a concept, and what it does is it says flow of message. The message has to flow from one neuron to other neuron. Now it has to be based on some mathematical calculation, and we say it's an activation function. The concept is I can go from here to here as well, or I can go from here to here as well. Why would I go from here to here, then here to here? This is all based on this mathematics. Right? So each neuron performs a simple calculation like weighted sum followed by a nonlinear function on its input. So this is the input. It uses this like x1 times 0.8, which is the weight, plus x3 times, if you see 0.2, plus the bias, right? And neural networks learn to perform tasks by considering examples, what we learned, generally through task-specific programming. They might learn from identify images, contain cats by analyzing images and non-cat images, right? So you are feeding so many millions of images. If you are feeding it, it would be able to identify what is a cat or which is a dog. So the connection between neurons have weights that adjust as the learning proceeds, right? And the good thing about these neural networks is as they are learning, they can adjust these weights and biases as well, right? So the network also uses biases, which is an extra input to the node, right? So it is all it is doing with these weights and biases, they are helping in your decision making. Which neuron do I need to go to, right? And some examples, I won't go into the detail. We have image recognition, speech recognition, predictive text, right? Okay, now we talk about what is actually happening, and this is really the magic part. So again, we will study transformer, right? And they coined this term transformer, right? And they said transformers are a type of neural network that revolutionized the field of NLP. And what are the key points? Now, again, I thought, why the name transformer? So have you studied in physics that a transformer is something that looks like this? It has these set of coils, it has these set of coils. The purpose of a transformer is to transfer the electric current from one circuit to another circuit, right? That's all what a transformer does, right? And if you go and study the architecture of transformer, you'll be surprised it's the same architecture, right? So they have taken the concept of encoder and they have taken a concept of decoder. And again, with encoder and decoder, there are multiple layers involved, right? So there's so many layers of encoder, and encoder is something on the input side. When you're giving a text, write me a poem, it is getting converted into embeddings. Those embeddings of vectors, we say vectors, it's an array of numbers, are actually fed to the next neurons. Then comes the output part. Then that output is getting given back to the user. So this is all the magic that is happening is nothing but an encoder and a decoder, right? And then they say there is something called an attention mechanism. And it says the transformer's core is attention mechanism, which helps the model focus on relevant parts of the better understand the context, right? Now, this is where these models are so good. They understand the context and the relationship. Now, the best example with context I give is bank of a river, money in the bank, right? It's the same word, right? But it has the intelligence. It knows bank of the river is different from money in the bank, right? This is called attention mechanism. And this attention mechanism is carried forward through the different layers. This context is carried forward through the different layers when it's generating the text, right? Here it gives an example, write me a story. You pass through the transformer and you get a softmax. So softmax is something, it's another layer that turns the scores into probabilities and that are used to pick the next word. You know how it creates a story. That's really the amazing part. Now it says, if I have to write a story today, I could start a story using this word. Maybe I could start a story from somewhere, there, sometime back, right? But it says most of the stories are normally starting with once. If you see the weight of this is, or the weightage of this is 0.5. Out of these neurons, it will activate this. It will say, hey, once. Then it goes to other neurons. Now, other neurons could be once there, once upon, once somewhere. Probably this is 0.1, 0.2, this is 0.6. Sorry, 0.8, right? So it will pick upon. Oh, every story normally starts with once upon, and this is how it starts generating the text. Once upon a time there was a, right? This is the magic. Okay. So, and anyways, and these are always run in a parallel manner. They are highly scalable. And this is a layered structure again. As I said, this encoder decoder has multiple layers of self-attention and feed forward. Self-attention means you're taking the context over and you're feeding it forward. That's the whole thing, right? So it is doing a concatenation of these blocks, and each of these is composed by attention component and feed forward, right? So your context is being sent and you are sending it out. This is how it goes, right? And again, some applications are machine translation, text generation, and this. Okay. So very quickly, we'll take a look at generative AI. Now we are in this. See, to learn Gen AI, you have to go from here, then you come here. Anyways, so with Gen AI, the main aim is content creation, right? You're creating your content. I don't have to explain it. It could be text, image, music. You learn from the data because at the back end, it's deep learning, machine learning. So these systems learn from large data sets to understand the patterns and styles, right? And you'd be surprised to know, if you don't know, that ChatGPT, they have done this training on the whole of, they say normal whole of the internet. Whatever data is available on the internet today, they have trained their models on that, right? Telegraph newspaper, books, newspapers, everything, articles, they've trained their model on that. So this is where I say quality, quantity. And many Gen AI systems use deep learning, particularly neural networks, to generate content. Now, I think you can easily correlate whenever somebody talks to you, hey, you know, Gen AI is based on deep learning. You say, yeah, I know deep learning is based on neural networks. What happens in neural networks, I already know, right? Gen AI is used in various fields such as art, entertainment, marketing, software development, and any field you are working in, it will actually be used. And it's improving the efficiency, right? By automating the creation process, it can significantly reduce the time and effort required to produce content. Just think about it. A content writer. Today, you have to submit something. You put it in your ChatGPT and gives you within seconds, right? You have to create a report. You have to create a summary. It can do it for you very quickly, right? Obviously, there are concerns regarding originality, right? Copyright, potential misuse of the generated content, right? Now, normally, if you go to Google, you get an image. It's basically, there would be copyright images, but not for Gen AI, right? So some rules need to come up on the originality, copyright. And by the way, where I showed the live demo, you remember that photograph I showed? That was also created using Gen AI. I used meta.ai to create that image, because I thought I'm doing Gen AI, so why not use that? And these systems can start with simple user input like text prompt and go to more full-fledged creation, right? You can create code, you can create advanced code. All these capabilities are there. Now, very quickly, we can take a look at predictive AI versus Gen AI. So till now, everything was predictive AI. Why predictive? Because you were giving patterns, or you were studying the patterns, you were making predictions, right? We were all happy in our world. We were living in the world of predictive AI. Now, another good example is like on your phone, if you're writing, hello, how are, it predicts that next text could be, how are you, right? But here we are saying generative. From the scratch you start. You write me a story, you write me a poem, right? So the function with predictive AI is to analyze the existing data and make predictions about the future events. And Gen AI says you are creating new data, right? That resembles the training data, often creating entirely new or original output. Data analysis. So normally it involves statistical methods, as we saw, and they are based on machine learning. Here, the aim is content creation, right? It's not only content. It could be image, it could be video, it could be text, it could be a code. Lots of things can be done, right? And applications normally used for weather forecast, right? Because based on certain say features, you can predict. That is what weather forecasting is all about, weather prediction, weather forecasting. Your stock price prediction, we were using it here. Then with Gen AI, we are using in art, design, generating synthetic data, training other AI models, and creating realistic simulations. Okay. And decision support, like they were used for recommendation systems, like I showed you the perfect example of machine learning, where you are sent that, hey, why don't you take these courses together? Or why don't you actually watch this movie? Recommendation systems, right? These are more creative, right? You are producing creative and novel outputs, which goes beyond the scope of the input data, right? And these are reactive. So predictive was always reactive, right? You're fetching, you're giving the data, you're getting the output, right? So it used to react on the existing data. This is proactive, right? That's why it's a game changer. Proactively creating new data points. You can even generate synthetic data. You say, oh, today I want to learn machine learning. Can you create me a nice data set for machine learning? It will generate it for you. Right? Again, examples are credit scoring models, demand forecasting, all this. And with deep learning models are GPT, DALL-E, and all this. Okay, very quickly, did you know that, did anybody actually know the full form of GPT? When ChatGPT came, did you know that what does GPT stand for? I didn't know. So anyways, so GPT stands for Generative Pre-trained Transformer. Can you now correlate to whatever we studied, how it falls in place? Generative, this is generative AI. It's pre-trained. Yes, it's trained on vast amount of data, websites, books. Transformer, the magic model, the magic neural network model we learned about. Transformer, this whole thing works on transformer, which helps to understand the connections between words, context, emotions, right? So I think only a few minutes are left, so I'll quickly go ahead. So GPT stands for Generative Pre-trained Transformer, right? It is a type of AI model. It is a type of LLM, large language model, that uses deep learning techniques. I don't have to explain that. It is pre-trained on a vast corpus of data. As I told you, they used the entire internet, probably books, websites, novels. It has got generative capabilities. It can generate context relevant text. That is why we say context. That self-attention mechanism is very important. And it has evolved. The versions, like it started from 1 back in 2018. In 2023, it came with 4. Recently, it came with 4.5. 5 is already in the making. Then they came up with O1 model. They came up with O3 model. And these are based on reasoning. I won't go into deep dive into reasoning because then it takes another half an hour for me to speak. But anyways, and this is the kind of roadmap they are looking at. So GPT-4o, now 4.5 is already there in the market. Now they are looking to bring 5, where they will make it as a single unified model, where initially this was O1 and this is O3. So these models were forward thinking, like they always used to go forward. But with O1, they were doing reasoning, right? Something what DeepSeek does, right? So it's reasoning, it's looking, am I making the right decision? Only then it goes ahead, right? And it can go back as well. And these are some of the applications. Okay, quickly, very quickly on AI infrastructure, right? Now, there is so much talk about GPUs, right? All the time we say, hey, why is NVIDIA so important? Why NVIDIA shares are so important? Why the AI models work on GPUs? To be honest, I've always worked in the field of IT. I've always worked in the field of, say, databases. We were quite happy with CPUs, what the CPUs were doing. I've even worked on Exadatas where we have hundreds of CPUs, right? And mission critical jobs, transactions, payments are running on that. Oh, why this sudden talk about GPUs? I used to even think like, what's the major difference between a CPU and GPU? I used to get confused. So GPU is nothing but a graphics processing unit, right? It is highly parallelized. It's very, very much parallel. Its entire architecture is based on parallel processing, right? And do you know, it was when NVIDIA actually came up with GPUs, they never had AI in mind. They had graphics in mind because they were doing, or their research was going towards gaming because they wanted to create it for 3D animations, video games. But suddenly when this Gen AI wave came, everybody started saying, hey, I need compute, because you think, you can very well imagine, right? You have to train your model on your internet data. How would you do that? You need compute for that. And from where do you get the compute? Your CPUs will die, right? They can't train. They can't use that much of compute. So this is where GPUs come, right? And in the field of AI and machine learning, GPUs are instrumental for training complex neural networks due to their ability to handle multiple operations. Now, GPUs are essential for virtual reality, augmented reality, right? And the technology behind GPU continues to evolve rapidly. As you know, They keep coming up with new things. And this is a very quick comparison between CPU and GPU. So CPU stands for Central Processing Unit, GPU, Graphics Processing Unit. We're talking about something like 4 to 8 cores, probably with Exadatas, hundreds of cores. But here, we're talking about thousands of cores. CPU is based on low latency, right? This is based on high throughput. You want to do a big job quickly, right? Here, it is latency. CPUs, they say, is good for serial processing, one at a time. You do one thing, okay, the CPU takes the other task, it does it. This is good for parallel processing. The aim with CPU is to quickly process the tasks that require interactivity and breaks the job into, GPU breaks the job into separate tasks. And CPU has always been used for traditional programming, and CPU and GPUs are used for parallel execution. All good in terms of theory. But do you know, I was still not convinced. I said, I'm still not convinced. I still can't make it. What is a comparison between a CPU and GPU? Then I started looking and I came across this video. And you know, this video was released almost 10 to 12 years back by NVIDIA. And what they did in this is they are showing a comparison between a CPU and a GPU 12 years back when they released GPUs. And what they're going to do is they're going to paint a picture of Mona Lisa and they'll show you the power, what a CPU can do and what a GPU can do.
And he is going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
when we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
And 10,
9,
8, 7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is next.
Okay, thank you guys. Let me come back. Stop presenting. Yeah. That was the end of the... I didn't realize there was so much of sun coming. Okay. Good. Right. Any questions anybody has, or any feedback, anything you learned, you already knew something was missing, or something could have been added? Because the aim was to actually bring everything in 1 hour, because that's what my aim was. I understand it's a Saturday, people have come. I didn't want to go to beyond that limit as well. So do let me know. And if you have any questions, feel free to put it in the chat as well. I hope everybody is or has actually joined our WhatsApp community. If not, just feel free to join, and please feel free. It's a free link, right? Please feel free to join or let others get added. You can always add your friends. I've allowed that. It's not I'm an admin, only I can add. You guys can add. If you want to say put it on your LinkedIn, anything I post, feel free to repost it as well, right? So yeah, that's pretty much I had for today.
Thanks a lot, Kshitij. It's been excellent. I think people are commenting, but yeah, it's been a great presentation and for doing this. Thank you so much.
Thank you, Chirag. Thank you.
Very
Okay,
good session. Thank you, Kshitij. Very useful.
And feel free, as I said, try to send your questions if you have on the group chat, so that probably others could learn as well. And no question is big, small, weird. I always say, think about it. Like when I was studying, I was not happy. CPU, GPU. People say, oh, we know GPU, but I didn't know what a GPU is. I wanted a quick comparison. So if you have any questions, just put it in the chat. And yeah, we'll work on that. Okay. Thank you guys. Thanks for coming on a Saturday. Cheers.
Bye. Cheers. Thanks, Shretaj. Bye.
Thanks. Bye. Bye.
Thank you.
Bye. Bye.